Good morning, students. Today we are going to begin with a new chapter, Analytical Chemistry. What do you understand by the term analytical chemistry? Something to do with analysis? Analytical chemistry includes both qualitative analysis and quantitative analysis. Now, what do you understand by the term qualitative analysis? Qualitative analysis reveals chemical identity of elements or ions in a given sample, whereas quantitative analysis determines the relative amounts of each substance in a given sample. That means you're going to calculate weights or volume. It means something to do with what? Measurement. Now, before we start with colors of salts and their solutions, keep in mind you got to know the meaning of these two terms, qualitative analysis and quantitative analysis. Now, let us take a quick look at color of salts and their solutions. To begin with, we are going to start with cations. Cupric ions, the symbol is Cu2 positive. The color is blue. Ferrous ions, the symbol is Fe2 positive, light green in color. If it is ferric ions, Fe3 positive, which is either yellow or brown in color. Nickel ions, Ni2 positive, is green in color. Chromium ions, that is Cr3 positive, is green in color. Manganese, Mn2 positive, which is pink in color. Cobalt, CO2 positive, which is blue in color. Of course, when you are doing the experiments in the laboratory, very soon you will be acquainted with these colors. However, till then you have to memorize the list of these colored cations. Now we move on to colorless cations. If you know the colored ions, then the rest will be colorless ions. For instance, sodium ions, Na positive, these are colorless. Potassium ions, K positive, these are also colorless. Magnesium ions are also colorless. Calcium ions are also colorless. Barium ions are colorless. Aluminium ions, Al3 positive, they are also colorless. Lead ions are also colorless, Pb2 positive. And zinc ions, Zn2 positive, is also a colorless cation. Now, let us study the colored anions. Anions means negatively charged ions. First one, permanganate. How do you write it? MnO4 negative. The color of permanganate ions will be pink or purple. Number 2, dichromate ions. How do I write it? Cr2O7 carrying 2 negative charge. Orange in color. Chromate ions, CrO4 carrying 2 negative charges. It is yellow in color. So you have to remember only these three. Permanganate ions, which is pink or purple. Dichromate ions, orange in color. And chromate ions, which is yellow in color. Now let us take a look at colorless anions. Sulfite, Sulphite, sulfite ions, SO3 carrying 2 negative charge, is the colorless ion. Similarly, sulfate, SO4 2 negative. Carbonate, CO3 carrying 2 negative. Chloride, Cl1 negative. These are all colorless anions. Similarly, bromide, nitrate, hydrogen sulfide, hydrogen sulfate, these are also colorless anions. Then we come to bicarbonate, or we call it hydrogen carbonate, which is HCO3 1 negative. Then oxide O2 negative, which is also colorless anion. Sulfide S2 negative, which is also a colorless anion. Then phosphate is also a colorless anion. So if you learn the list of colored anions, the rest is colorless anions. Is that clear? Now, alkalis. When it reacts with metal ions in solution, it forms an insoluble compound called precipitate. Okay, so alkalis react with metal ions in solution to form insoluble compounds called precipitates. Then what is the process of precipitation? Precipitation is the process of formation of an insoluble solid when solutions are mixed together. Now, you have to memorize the list of colored cations and colored anions. Next class, we are going to deal with the reaction between alkalis like sodium hydroxide or ammonium hydroxide with salt solutions. Please revise the lesson. Thank you.